The Smithsonian Museum of Natural History has over 147 million specimens, the largest collection in the world. Everything from giant dinosaur bones to delicate butterflies to pickled animals like this stonefish.
Most venomous in the world. Whoops.
But less than 1% of it's on display. The rest is tucked away in what's called collections, hidden behind the scenes.
All right, so this is our vault area, our secure storage area for the mineral collection.
It costs more than $100 million to run the museum, and it's mostly funded with taxpayer dollars. So why does the US government spend so much money on things most Americans will never see? Well, the specimens aren't just sitting here gathering dust. They're actively used for research, with big impact.
This is what caused the airplane to land in the Hudson River.
But flooding could endanger it all. We went inside the secret collections in Washington, D.C. to see how they acquire, clean, maintain, and protect millions of specimens. This is how much of the Museum of Natural History you can see. But the hidden collections make up the rest of the space, more than 1.4 million square feet, spread across the museum and the off-site support center. There are 7 different departments, from entomology to paleobiology, and the collections are constantly growing. Visiting the museum is free to the public because it's government funded through tax dollars, but researchers here can't use tax money to acquire new objects. So how do they get them? Well, they're either collected in the field, donated, or purchased with endowments. For example, this giant Arkansas crystal was donated to Mineral Sciences in 2021. We don't know exactly how much it cost, but estimates put it in the millions. Over in entomology, scientists collect half of the new insects in the field and get the other half from donations.
As people retire and they're looking for permanent homes for their collections, those often come to us. These are the tailless whip scorpions, so anybody who watched Harry Potter would recognize these. They're actually really docile, they're easy to handle. You can actually get these as pets.
But getting dinosaur bones is much harder.
So here's some of the dinosaur material.
Paleontologist Hans Seuss is up against a growing market of private collectors.
Started after those awful Jurassic Park movies when everybody decided to have a dinosaur in their living room. People now think that if they find a toe bone, they should get enormous amounts of money for it.
And since they have to rely on endowments, museums can't compete at million-dollar auctions.
Often commercially collected fossils have no detailed locality information, and that makes them scientifically almost worthless.
So all Hans can collect are bones he finds on federal lands, or smaller ones he can purchase with donations. But some collections at the museum are just really old. Today, bird researchers rarely collect specimens in the wild.
This bird was collected in 1904.
And if they do, it's from healthy bird populations.
Today we take tissues, we take song recordings, we keep skeletons, we make spread wings. So we have a lot more parts of the bird that we save. And it's our ethical responsibility to do as much as we can with the specimen if we're going to take it from the wild for research.
Once a specimen is purchased or collected in the field, it's transported to the museum. Specimens like that giant crystal then go through a process called accessioning.
Is where the museum inspects the objects so they can take ownership of it, make sure that it's in good shape when we receive it here at the museum.
The museum acquires 300,000 specimens a year to reflect the scale and the diversity of the natural world. Once the museum accepts an object, it has to get cleaned. Out at the museum support center, any recently living creatures are cleaned using beetles that really like to munch on dry skin.
They're a little bit more free-roaming in the larger chamber. There's nothing really containing them except for trays.
You don't want rotting flesh in storage.
We currently have a sea turtle, elephant, dolphin skulls, and I believe there's a wallaby in there.
Cleaning dinosaur bones takes even more work.
We'd be lucky if all we had to do was just dust them off. They're encased in their host rock, which is what we call matrix. And that matrix has to be removed little by little, bit by bit.
Michelle uses this machine, called an air scrape. It blasts compressed air at the rock. But how do they prepare something to be stored forever? Well, a dinosaur bone can't just sit on a shelf exposed. Over time, gravity would start to break it down. So most bones get a custom storage cradle, built out of fiberglass and plaster. It's basically a fancy Tempur-Pedic. Each costs about $800. They're pest and water resistant. Hans wants them to last because he loves his fossils.
I'm kind of a wallflower, but you tell people that you're a paleontologist at the Smithsonian and you're suddenly the center of attention.
On the other side of the museum, some of the older animals got stuffed.
Squirrel.
And some get pickled.
When you pickle a whole organism, you can study not just their fur and their skeleton, but their internal anatomy and all that kind of stuff.
Everything from a polar bear embryo to bats to giant fish are stored in alcohol. These fish come from all over the world.
So see, these do not fit in jars, and the cheesecloth is to keep them from drying out if the level gets low. So the coelacanth, they thought it was extinct, and in 1938, it was discovered in South Africa. It was a very big deal, as you can imagine.
Over in entomology, the insects get dried and pinned, so they're temperature stable. Then Floyd and his team put them into these hydraulic carriages.
We have 35 million specimens in the collection. We have over 400,000 species represented in our collection, which is more than all the other departments combined. Since insects are essentially our only major competitor for food, and because they have such a profound impact on human health.
Each of these storage techniques is designed to last indefinitely. But while the researchers have done all they can to safeguard these precious objects, it's unclear how much longer they'll be able to do that. The National Mall was once a marsh, and today it sits in the floodplain of the Potomac River.
We're literally at sea level here. So one thing I've been doing is this year moving all collections out of the basement of this building up to higher floors.
As the climate's changing, flooding from heavier rainstorms and the Potomac are a growing threat.
Water seeping into basements along the mall and threatening the treasures of the nation. The Smithsonian will tell Congress tomorrow it's $1 billion behind in needed repairs.
It's already happened to the museum next door, leading to millions in damage. And the National History Museum is next. But Congress has been slow moving to fund improvements.
So we're going to have to start armoring the mall with larger and larger dikes.
The museum does plan to expand the off-site support center. It's farther above sea level, so researchers have started moving more specimens out there. For now, to preserve its collections on the National Mall, the museum has begun creating digital scans, starting with easier-to-handle objects like plants and flowers.
All of our flowering plants have been digitized so far. That is about 3 million plant specimens that we have run on this conveyor belt.
Today, this digital archive has over 9 million specimens, but the museum is still years away from getting the entire collection online. So why put in so much effort to store things most people will never see? Well, for research.
So think of a museum not just as a place that displays stuff, but a place that studies and understands stuff as well.
The collections are essentially a living library that 12,000 visiting scientists can access. And their work has real-world benefits. In mineral sciences, scientists across the globe can ask Jeff for a piece of any of his rocks for research.
This is our reference mineral collection. So this is the part of the collection that gets used primarily for scientific research.
The department also monitors and tracks volcanic activity around the world. Pickled mammals are studied to find out which species can transmit diseases.
One of the ways we study those diseases is to find the mammal host for the virus.
Whenever a bird strikes a plane in the U.S., samples of it are sent to Carla Dove in vertebrate zoology.
The colors and the color patterns on some of these birds is just amazing.
Yes, her last name is Dove.
Yeah, I get that all the time. My name is very appropriate. Okay, so I'm just coming from the mail room where I picked up the Daily Mail. These packages all have specimens of bird remains or some kind of wildlife remains that were scraped off of aircraft.
And Carla gets 10,000 of these packages a year.
This is a part of the horizontal stabilizer, what the bird hit and caused the damage to. And you can see all of this bird ick on here, which is what we refer to as snarge, or bird tissue.
Bird strikes cost the airline industry billions in delays and damages. Remember the 2009 crash landing in New York City?
Less than a minute into the flight, the pilot reported a double bird strike.
In that case, we got 69 bags. Because as they went through and did the investigation, they went all the way into the engine and they wanted to know how far into the engine the feathers went.
Her team then uses these mailed-in bird remains to identify the species involved in the strikes.
Oh, this one here, do you know what this might be, Carla?
It looks kind of like a black vulture.
There you go. It's one of her favorite birds. No, chicken is her favorite bird.
If she can't identify a sample right away, Carla can compare its feathers to one of the 500,000 specimens in the museum's collection.
The location of this strike was Florida. So we look at all of the possible herons in Florida and we match it up perfectly with an American bittern. And this piece of beak just so happens to fit perfectly with the beak of the specimen.
Aeronautical companies use Carla's data to develop planes that can withstand bird strikes.
If you know what the species of birds are that cause these problems, you can go out onto the airfields and do habitat management to keep those birds from wanting to come in to these environments.
And based on her research, Air Force units have adjusted flight trainings,
thereby reducing the risk of bird strikes, but also, we like to say, saving birds too.
But we've barely scratched the surface of the museum's countless research initiatives.
We're collecting specimens so that scientists 50 years from now or 100 years from now will have access to the same diversity we have right now.
And we may never know how important these collections may be for scientists in the future.
Museums are the memory of our culture, and they're the memory of our planet. And imagine the Smithsonian of the year 2400. It'll have specimens from this time that will be a distant memory to the people then, but it will tell the story of planet Earth.